Hello everyone, welcome you all to this presentation. In this video, we will see about what is push down automata and its definition, and we can see how we can construct the push down automata for a language with some examples. Okay, these are the contents of the presentation. First we see about the introduction, then definition, then instantaneous description of PDA, then PDA construction with some example. Then we see about the language of PDA and the summary. Next we see the introduction. So what is push down automata? Okay. So push down automata is a finite automata with extra memory called stack. Okay. First you see what is finite automata. So finite automata is a abstract model of a computing machine. Okay. So the finite automata with the extra memory called stack is called as a push down automata. Okay. And why you are going for push down automata? So it is for recognizing the context free languages. Okay. So in the previous presentation we discussed about what is context free language. Okay. So you know what is context free language? So it is a language generated from the context free grammar. Okay. The set of strings accepted by the context free grammar is called as a context free language. Okay. For recognizing context free language you go for the push down automata. Okay. So next you see the model of a push down automata. Okay. So if you see the model, okay, it have a finite state control. Then we have two things. Okay. So first we have a input tape. So in addition to the input tape, it have one more extra memory that is called stack. Okay. So for any transition, so it depends on the input as well as the stack content. Okay. So based on that, it will either accept the input or reject the input. So this is a model of a push down automata. So next you see the definition of push down automata. Okay. So how we can define the push down automata? The push down automata can be defined using a 7 tuple. Okay. So for example, consider we have a push down automata. So that is represented as P. So it have 7 tuples. Okay. So the first one is a set of states. Second one is a set of input symbol. Third one is a set of stack symbol. And fourth one is a transition function. And fifth one is a initial state. And the sixth one is a start symbol of stack. And the last one is a set of final state. Okay. So using these 7 tuples, we can define the push down automata. Okay. So first we have a finite set of states. Q represent a finite set of states. And sigma represent a finite set of input symbols. And the gamma represent the set of stack symbols. And del represent the transition function, and Q0 represent the initial state, and Z0 represent the start symbol of the stack, and F represent the set of final state. Okay. So using these 7 tuples we can define the push down automata. So next we see the instantaneous description of PDA. Okay. So simply we call it as a ID of PDA. Okay. So here it tells about how a PDA computes the input string and make a decision that the string is accepted or rejected. Okay. So using this we can check whether the string is accepted or rejected by the push down automata. Okay. So here in ID we use 3 values for representing the configuration of PDA at any time. Okay. So the instantaneous description of PDA, it is used for representing the configuration of PDA at any time. Okay. So it uses a triple format. So it have 3 entities. So one is a state, and next one is a remaining input, and next one is a stack content. Okay. So for example, consider we have a move like this. Okay. We have a transition like this. Okay. Q0, AW and Z0. Okay. Where Q0 is a state and AW is the remaining input and Z0 is the stack content. Okay. So after this move, the stack configuration will be Q1, W, Y, Z0. That means, so after consuming the current input symbol A, it goes to the state Q1. Again the stack content will be Y, Z0. Okay. And this will be possible if and only if you have the transition like that is del of Q0, A, Z0 equal to Q1, Y, Z0. Okay. So this is what we are using this notation. We are using this instantaneous description for processing the input string. Okay. So next we go for the construction of PDA. Okay, so how we can construct the PDA for a language. Okay, so consider we have a language. Okay, L equal to WWR, where W is the element of 0, 1 the whole star. Okay, so first we have set of strings of zeros and ones, that is in W, and next we have the reverse of W. Okay, so the possible strings are 0 0 1 1, then 0 1, then 1 0, that is the reverse. Okay, and then consider W is 0 1 1, then WR is 1 1 0 and 1 0 1 0 1. Okay, like that we have derived any number of strings. Okay, so what we are going to do is we are going to construct the push down automata for this language. Okay, so first we see what are the steps we have to consider. Okay, so initially we use the symbol Z0 to represent the bottom of the stack. Okay, so in the stack there is no content, that is empty. So here we are using the symbol Z0 to represent the bottom of the stack. Okay, and then we consider we are start from the start state Q0. Okay, we are start from the state Q0 and we have to read the symbols present in W. Okay, so whatever may be the symbol, okay, 0 or 1, how many symbols are arrays. Okay, so whatever may be the number of symbols, what you do is you have to just push all the symbols in W into the stack first. Okay, and then you assume that we see in the middle and you go to the state Q1. Okay, and then when you are in the state Q1, what you do is, so you have to compare the input symbol with the symbol at the top of the stack. Okay, and if there is a match, what you do is you have to do the pop operation. You have to do the pop operation, so you have to pop the symbol from the stack and move to the next step. Okay, so at the end the stack becomes empty, so it implies that W followed by WR, the string is accepted by the push down automata. Okay, so this is a concept for implementing this push down automata for this language. Okay, so we will see how we can define the push down automata for this language. So the push down automata can be defined using 7 tuples. Okay, so first we have the finite set of states, then we have a finite set of symbols, then we have a stack symbols, then we have a transition, then start state, then start stack content, and then we have a finite set of final state. Okay, so these are the 7 tuples for representing the push down automata. Here I assume we have 3 states. Okay, so Q0, Q1 and Q2. Okay, and then symbols are, input symbols are only 0 and 1. Okay, and stack symbols are 0, 1 and Z0. Okay, then we have del, then we have the starting state is Q0 and initial stack content is Z0 and the final state is Q2. Okay, so next to see how we can write the transition function del. Okay, suppose consider first you are in the state Q0. Okay, so what you do is you have to consume the symbols in W. Okay, so whenever you read the symbols from W, what you do, you have to just push the symbols into the stack. Okay, so initially you assume you are in the state Q0 and the initial stack content is Z0. Okay, so so we can receive either 0 or 1. So what you do is you have to just push the particular symbol into the stack. Okay, so the first transition is del of Q0 0 Z0 equal to Q0 comma 0 Z0. Second one is Q0 1 Z0 equal to Q0 1 Z0. Okay, so in this case we inserted one symbol into the stack, that is either 0 or 1. Okay, so in the next case what happened is, so now in the top of the stack we have either 0 or 1. Okay, if I assume, okay, so in the top we have only first 0. Okay, so next possible symbol may be either 0 or 1. Okay, so in this case again what you do, you have to push the symbol into the stack. Okay, similar way, so you consider in the top we have 1, so again the possible symbols are either 0 or 1. So what you do, just you push the symbol into the stack, so the 4 transition will come. Okay, so now we are not changing the state, we are in the same state alone. Okay, so in the state Q0 what you do, so you have to read all the symbols in W and push it into the stack. Okay, so this is the first set of transition. Okay, so next what you do is, in this case you assume, so you meet the middle of the particular language, okay, that is W, okay. You read all the symbols in W, okay. So what you do, so in the next step you have to move to the next state, that is from Q0 to Q1 you have to move, okay. So without reading any input symbol, what you do is you have to move the next state, okay. So from the state Q0 you read the symbol epsilon, okay, that means empty string. You go to the state Q1, okay. So in this case no change in the stack content, okay. You are not pushing any symbols into the stack, okay. So already we have three possibility, either the stack may be contain Z0 or 0 or 1, okay. So you will read the input symbol empty string, that is without reading any input symbol. So you go to the state, okay, there is no change in the stack content, okay. Then what you do, so you have to read the symbols present in WR, okay. So in that case what you do, you have to compare the symbols on the input along with the symbols present in the top of the stack, okay. So if there is a match, okay, so you are in the state Q1, now you are checking whether the input symbol is matched with the top stack symbol. If there is a match, what you do, you have to just pop the symbol, so Q1 comma epsilon, again you are in the same state, okay. Okay, and then Q1 0 0, okay, del of Q1 0 0 equal to Q1 epsilon, and one more transition is del of Q1 1 comma 1 equal to Q1 comma epsilon. What does it means, so you just pop the symbol, okay, so it is epsilon here, okay. So this is what the transition present in the state Q1, okay. So once you read all the symbols in WR, so what you do is, so there is no symbols, okay, so no more symbols in the stack, so you move to the final state, okay. The stack is empty, the stack having only Z0, without reading the input symbol from the state Q1, you move to the final state Q2, okay. So in that case no change in the stack content, stack having only Z0. So now you see the stack is empty, all the symbols in W as well as WR is matched, okay, all the symbols are popped out from the stack is empty, so we can say W is followed by WR, so the string is accepted by the push down automata, okay. So this is a way we can construct the push down automata, okay. So next we see the transition diagram of a push down automata, okay. So this is what a transition diagram of a push down automata. So in the previous example we have three states, right. So one is Q0, Q1 and Q2, right. So in the Q1 state, so these are the 6 transition. So here each and every label represent 3 things, okay. So the first one represent the input symbol, and the second one represent the initial stack content, and the slash represent, after the slash represent the stack content after reading the input symbol, okay. So before and after the transition, so what will be the stack content, okay. So that is represented using this, okay. So for each and every edge, okay, so we have a label, so it represents the input symbol, then before as well as the after the content of stack, okay. So this is a way we can draw the transition diagram of a push down automata, okay. So next one is the acceptance of a string, okay. We are checking whether the string is accepted or not, okay. So using this previous push down automata, okay. So in the previous push down automata, so we consider the language WWR. So consider one of the string 0 1 1 0. So here 0 1 is W and 1 0 is WR, okay. We are checking whether the string is accepted or rejected, okay. So we start from the initial state Q0 and the current input is 0 1 1 0 Z0, okay. So Z0 is the initial stack content. So here you are using the standstill notation, okay, standstill notation, okay. So first you assume you are in the state Q0 and first you are reading the first input symbol. So what you do, you have to read the symbols in W, so you have to just push the symbol into the stack, okay. So after this transition the stack content will be 0 Z0, okay. So the configuration of PDA is Q0 comma 110 comma 0 is a 0. Okay, where Q0 is the state and 110 is the remaining input and 0 Z0 is the stack content. Okay, so in the next step you will read the next input symbol, that is 1, that is Q0 10. Okay, again what you do, you have to push the symbol into the stack. Okay, so this will be the configuration. So now you reach the middle of the string. So what you do is you have to move to the state Q1 without reading any input symbol. Okay. Then what you do? So now you have to compare. Okay. In the state Q1, you have to compare the input symbol along with the symbol present in the top of the stack. If there is a match, what you do? You have to pop the symbol. Again, you are in the same state. Okay. And then again, so you read the remaining symbols of WR. So here 0, 0. Again there is a match. It will be popped out. Okay. Now you see there is no remaining input, that is epsilon. And then here in the in the stack also there is no symbol other than Z0. Okay, all the symbols are popped out from the stack. Okay, now what do? You have to move to the next state. Okay, that is the final state. So Q2 is the final state. Without reading the input symbol from Q1, okay, it moves to the state Q2. Okay, now you reach the final state. So we can say the input symbol is accepted by the push down automata. Okay. So this is a way we can decide whether the string is accepted or rejected using instantaneous description of push down automata. Okay. So next we see the language of push down automata. Okay. So you know what is language, right? So the language is a set of strings accepted by the push down automata. Okay. So next we see how we can define the language of a push down automata. Okay. So there are two ways to define the language of push down automata. So one is the acceptance by final state and other is the acceptance by empty stack. Okay. So in case of acceptance by final state, what happened is, so after reading entire input symbol in the input string, so it reaches the final statement, we can say the given string is accepted. Okay, that is present in the language of push down automata. Okay, and in case of acceptance by empty stack, what happened is, after reading entire input symbol in the input string, it empties the stack, means we can say the given string is accepted by the push down automata. So it is also present in the language of push down automata. Okay, so we will see one by one. Okay. Okay, first one is the acceptance by final state. Okay, so we are going to define this. Okay, so consider we have a push down automata P. It can be defined using 7 tuples. So the language accepted by the final state can be defined as L of P. Okay, so which is equal to set of strings W such that, so you start from the start state Q0 and the initial stack content is Z0. So after reading all the symbols in W, it reaches any one of the state of final state. Okay, so where P should be a final state, it is one of the state in the final state. Okay, so after reading the symbols in W, if it reaches the final state, means, so we can say the given string is accepted by the push down automata. Again, the string W is present in the language of push down automata. Okay, so after reading, okay, so after reaching the final state, so here the stack content may be any content. Okay, it is not empty. Okay, only thing is it should reach the final state. Okay, so we can say this is a acceptance by final state. Okay, so next one is acceptance by empty stack. Okay, so in this case also we will consider one push down automata N. Okay, so it is defined using 7 tuples. Okay, the language accepted by the empty stack can be defined as set of language, okay, that is L of N, which is equal to set of strings W such that, so after reading entire input symbols in W starting from the start state and the initial stack content is at 0, so it empties the stack content. Okay, it empties the stack content and it reaches any one of the state in Q. Okay, it may not be the final state. Okay, so this is what acceptance by empty stack. Okay, so in this case we can say the string W is present in the language of push down automata. Okay, so next you see the summary of this presentation. So in this presentation we discussed the basics of push down automata, instantaneous description and the construction of PDA with an example, and the language of PDA both by the acceptance by empty stack as well as reaching the final state. Okay, thank you.